Okay, good evening. Our topic for this session will be the what they call this derivation of the value of e. The value of e is the base of the natural logarithm. Okay, let's proceed. The problem is find the value of e using Maclaurin series of expansion. The value of E is actually 2.71828. That's the value of E, the base of the natural logarithm. For those who don't have a major in mathematics or didn't have a knowledge yet of advanced mathematics, actually the value of E was derived by using Maclaurin series of expansion under advanced mathematics. Okay, let's proceed. From our previous discussions under the long video format, the equivalent of e to the x in terms of, by using Maclaurin series of expansion, that is e as a function of x, hold on, that is e to the x as a function of x. Okay, it was derived, the given equation, the equation was actually derived by using Maclaurin's, that is e to the x as a function of x. And from our previous discussions, e to the x is actually 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial plus x to the fifth power over 5 factorial, and so on. Okay? Since we now know the equivalent of e to the x in terms of x on the right hand side, the problem is asking what will be the value of e. The value of e is actually equal to e raised to the first power. That is when x is equal to 1. So we just set the value of x to be equal to 1, so we could compute for e. Okay? Since the relation of e to the x by using the Maclaurin series is already given, so we will just substitute x to be equal to 1, and that is actually e. Because e is just actually e to the first power. Right? That is when x is equal to 1. Right? So substituting values, we follow this, right? So e to the first will be equal to 1 plus x plus 1 square over 2 factorial plus 1 to the third power over 3 factorial, okay, plus 1 to the fourth over 4 factorial plus 1 raised to the fifth power over 5 factorial, okay, and so on. Okay, we do not need the values beyond x to the fifth power. We will just start up to the x to the fifth. Okay, so simplifying this one, this will now be 1 plus 1 is 2. 1 squared is just 1. 2 factorial is 2. 1 cube is 1. 3 factorial is 3 times 2 times 1, which is 6. 1 to the fourth is just still 1. And 1 to the fourth is actually, or 4 factorial is actually 4 times 3 times 2 times 1, that is actually 24. And the last one, which we will include in our computation, that is 1 to the fifth power over 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1, which is actually 120, plus some very negligible values. And if we try to simplify this one, this is 2 is 0.5, 16 is 0.1667, or approximately 0.167. 1 over 24 is 0.04167 approximately, or 666, plus 1 over 123, that is 0.00833. And if we try to take the summation of this, it is approximately 2.718. Okay, So the base of the natural logarithm, which is e, was actually derived by using this Maclaurin series of expansion. Okay? And to check the validity of our answer, you just display 1. We will use the function e to the x. The function which is e to the x is under the second function, so we will press second e to the x. Hold on. 1, second function e to the x. The value is 2.71828, or approximately up to 3 decimal places. The value of e, the base of the natural logarithm, is 2.718. Okay, good evening from Los Angeles.